In this video, we're going to talk about quadratic forms, specifically about what it means for a quadratic form to be definite or semi-definite or positive. So just to recap, a quadratic form is something that looks like this. Say 6y squared, or let's call that x2 squared actually, because we're going to use the term y in other places. Let's call it 6x1 squared plus, I don't know, 8x2 squared. And there might also be, say, 4x1, x2. That's a quadratic form, right? And we can represent a quadratic form using x transpose, the vector multiplied by a, multiplied by x, the vector where a is a symmetric matrix. So, what does it mean for a quadratic form to be positive? What does it mean for it to be specifically positive definite, positive semi-definite, and then further, what does it mean for it to be negative definite and negative semi-definite, and what does it mean for it to be indefinite? These are terms you'll hear people describing quadratic forms by, and it's good to know what they mean. So, if a quadratic form is positive definite, it means that q is greater than, or q of x is greater than 0, so long as x does not equal 0. Because obviously, if your x vector and your x transpose vector are 0, it's going to equal 0. That's completely inescapable. But assuming those aren't 0, it's positive definite if it's always greater than 0. And it's negative definite if it's always less than 0. Again, for x does not equal 0. Okay, so we understand what it is for something to be positive definite and negative definite. What does it mean for something to be positive semi-definite? It just means that q is greater than or equal to 0. So it's never negative. And likewise, it can be negative semi-definite if it's less than or equal to 0. So it's never positive. And then it's indefinite if it doesn't satisfy any of these. Or in other words, if it takes on negative values and positive values. Now this is just a helpful term to characterize some things because obviously we're often trying to calculate this about quadratic forms. We're trying to figure out, will this term here ever be negative? And we discussed previously how we can use change of variable to figure that out. In fact, let's just go ahead and do this here. We've got 6, 8, 2, 2, and the change of variable, well, let's see, what are the eigenvalues? And you know what, I'm not going to do this one in this video, but if we were to change a variable operation this, and I'm just going to create a hypothetical, and we were to end up with, 10 x2 squared plus, I don't know, 6x1 squared. That's always going to be positive because you've got these terms and they're squared, so they have to be positive, and there's a positive symbol attached to both of these, so that can never be negative. It can be 0, but only when x1 or x2 are both 0. So this would be positive definite. Now, for instance, if we had 10x1 squared minus 10x2 squared, well, it seems to me that that's indefinite, because varying on judging by the magnitude of these two terms, that could be negative, that could be positive, that could be 0. Anyway, in this video we covered what it means for, and how we can describe quadratic forms as definite, semi-definite, indefinite, and obviously positive or negative for some of those. Thank you for listening.